Good evening, ma'am. This is Vidhi Dubey of class 9th G, roll number 53, submitting my maths multiple assessment. Today, I will tell you about infinity. So, let us start with a question. How big is infinity? Here is a thought experiment by David Hilbert, a German mathematician, to wrap our minds around the concept of infinity. The infinite room paradox. A hotel with infinite number of rooms, with no vacancy but always a space for new guests, and a hard-working manager to manage all the guests. One day, a guest entered the new hotel for a room, but there were no empty rooms. As there are infinite rooms, he told the guest in each room to shift to the next room. So the guest in room 1 goes to room 2, guest in room 7 goes to room 8, and so on, hence creating a vacancy for the guest in the first room. This method is applicable for any finite number of guests, as the number of rooms are infinite. For example, if 20 new travelers are to be accommodated, the old guests would be shifted from room n to n plus 20. Now, an infinite bus pulls down a countably infinite number of passengers from the bus who want a room in that hotel. The manager is confused. If he let the guests go, he will lose infinite amount of money. It won't make much difference though, as he is already earning an infinite amount of money. So the manager devises a new formula. Guest in room 1 goes to room 2, guest in room 2 goes to room 4, and so on. Now every guest has been placed in an even room, hence infinite odd rooms are empty, and the passengers filing off the infinite bus are moved there. But one night, the manager sees lines of infinite buses with countably infinite passengers to get accommodation in that hotel. The manager is very confused. But then he remembers Euclid's proof of infinitely many prime numbers. So he comes up with a new trick to allot the rooms. The manager assigns room to every current guest, room number 2 raised to the power of their current room number. For example, the current occupant of room number 7 moves to room 2 to the power 7, that is 128. Then the night manager takes first of the infinite buses and assigns them to the room number of the next prime, which is 3 raised to the power of their seat numbers. For example, the passenger of seat number 7 is assigned room 3 to the power of 7, that is 2187. It continues all for the first bus. He follows this method with the next buses following the next prime numbers. Like for the second bus, he takes powers of 5 and so on. Since all of these has 1 and natural number power of their respective prime numbers as factors, no rooms are overlapped. Although this leaves many rooms unfilled, but no guest is left. This paradox of an infinite hotel mainly deals with the lowest terms of infinity, namely the countable infinity or the natural numbers. If we were dealing with higher order of infinity like real numbers, we have no way to systematically include all the real numbers. For instance, the infinite hotel would have negative rooms in the basement, and the guy in room 1.5 would always suspect that the one above him in room 1 has more part of the room. So this was Hilbert's Infinite Hotel. Thank you for watching.